This is amazing. Now we can create AI research assistants completely locally on your computer using Ollama. So first we are going to search research articles using archive Python package. Next we are converting those articles into embeddings and saving that in a database, that is Quadrant. Next we are asking questions to large language model using Ollama to clarify any doubts you have from the research articles which you searched for. We're also going to create a user interface for that. That's exactly what we're going to see today. Let's get started. Hi everyone, I'm really excited to show you about AI Research Assistant. I'm going to take you through step by step on how to set this up using Ollama, Quadrant vector database, GPT-4all embeddings, and LangChain. Finally, we are going to create a user interface like this using Gradio. But before that, I regularly create videos in regards to artificial intelligence on my YouTube channel. So do subscribe and click the bell icon to stay tuned. Make sure you click the like button so this video can be helpful for many others like you. So the first step, pip install archive LangChain community, LangChain, GPT-4all, Quadrant client and Gradio, and then click enter. Next, make sure you download Ollama and install it on your computer. Next, Ollama pull Llama to 7B chat. That's the model which we are going to use now. Once that is done, create a file called app.py and then let's open it. First, we are going to import the required modules. Import OS, time, archive, Quadrant from LangChain community, PDF loader, directory loader, chat Ollama, chat prompt template, base model, string output parser, the runnable parallel and runnable pass-through, recursive character text splitter, and finally GPT-4all embeddings. I've already covered LangChain in detail before, step-by-step beginner's tutorial, which I will link those in the description below if in case you couldn't understand any of these steps. As we've seen before, each of these modules which we imported is used at each of these steps. So first we are going to search archive articles. First search archive papers and download them. So we are defining the directory and creating the path if it doesn't exist. So in this we are going to use archive Python package. This is going to search for any research articles regards to LLM and then going to return 10 results. You can increase the number of results if you want to, and we are ordering it descending. Next, we're going to download those papers and save them. So we are going to loop through the top 10 search results. We are going to download using download_pdf function, and it will automatically get saved in archive_papers folder. Next, we are going to load papers, concatenate them and split into chunks. As you know, embeddings normally, you need to load all those papers. That means you need to convert the PDF papers into actual texts, merge them together and split into chunks. Then we convert those to embeddings. I've already covered this in detail before, which I will link those in the description below. In simple, this is the process of retrieving and saving all those papers in database. So we are setting the list of papers, loading using directory loader. So this goes through all the PDFs which got downloaded in the previous step and it will get loaded using directory loader function. Next, we are going to load those papers. Next, for our reference, we are printing the total number of loaded papers. Now we are going to concatenate all the papers. That means combine all the papers. So we are looping through those papers and combining all the papers in one and storing in full text variable. Next, we are going to remove empty lines and join into single string. Just for our reference, we are going to print the total characters in the concatenated text. Next, we are going to split those into chunks using a recursive character text splitter. Next, the splitting happenings using create documents function, where you pass the full text which we called earlier. Now we are going to create Quadrant vector store and store those embeddings there. Quadrant equals Quadrant dot from documents. Then we are providing the paper chunks, that is the divided content. We are using GPT-4all embeddings and saving the data in this folder. So in this folder, a database will get created and it saves all these embeddings with the collection name called archive papers. Next, we are initiating the retriever. As we can see in this image, we have completed searching the archive for research articles. Then we converted those PDF articles into text, divided those into chunks using LangChain, and then converted to embeddings. Then we save that into Quadrant vector database. Now finally, we need to set up large language model using Ollama and ask questions from all the research articles which we searched for. So coming to the code, we are going to define the prompt template and initialize Ollama. That's the final step. So here is the prompt template. Answer the question based on only the following context. And we are providing the context and we are giving the question. The context is taken based on the question we search for from our archive papers collection. Now we're going to create prompt using chat prompt template function from template and then passing the template. Now we're going to initialize Ollama. Ollama LLM equals Llama to 7B chat. Next, model equals chat Ollama model Ollama LLM. We are passing this in here. Next, we are defining the chain. Chain equals runnable parallel. In this, the retriever is the context and runnable pass through is the question. The retriever searches in the Quadrant database based on the question we ask, so that the context we provide is more relatable to the question we are asking. Here we are passing the prompt, that is this prompt, and then the model, that is Llama to 7B chat. Finally, we are parsing the output using string output parser. These are the modules which we imported earlier at the top. Next, we are defining the pydantic question. Now we are applying input type to the chain. Finally, we're going to ask question. Result equals chain.invoke explain about vision enhancing LLMs. And we are going to print out the results. That's it. So for beginners, this might look complicated, but if you go through the videos which I've created before, this will be much more easier. But in simple terms, first we are searching the archive for researches related to LLM, that is the query, and we are downloading those papers and saving it. The second step, we are loading those papers, combining them and splitting them into chunks so that it can be converted to embeddings. Thirdly, we are converting that to embeddings and saving that in Quadrant vector store. Finally, we are defining our large language model using Ollama and asking question based on the context. Now I'm going to run this code. In your terminal, python app.py and then click enter. Now I can see the papers are getting loaded. A survey of large language models for code, benchmarking LLMs towards vision enhancing LLMs. Total number of pages loaded, 344. Total characters in the concatenated text, 1 million. Now the embeddings are getting created, which you can see from this folder. Temp, local Quadrant. There the collection name is archive papers. There you got the storage SQLite. So I'm just opening the database and browsing the data. So here you can see all the embeddings got stored. Totally 4,497 rows created from those 10 research articles. You can also see the list of research articles from this archive papers folder. So you can click directly here and it should automatically open all the list of articles which got downloaded. Now coming to the terminal, we got the output here. Vision enhancing LLMs is a method that leverages the vast knowledge and powerful text generation abilities of large language models, and it gives more details. So that's exactly what question we asked. This is exciting. Now you can extend this further to make it more advanced. I made it so simple that even beginners can easily understand. Now we are going to add user interface for this application using Gradio. Now I have modified the code a little bit, moved all those code into a function called process papers with query and question text. The query is used to search the archive database for research articles. Finally, the question is the question which we are going to ask to those research articles. Here we are returning the results and assigning the process papers function here in the gradio.interface. Input to text input, output is a text. And finally, we are launching it. Now I'm going to run this code. In your terminal, python ui.py and then click enter. Here is the URL. I'm going to open it. And here is the user interface. I'm going to type AI in healthcare. And the question I'm going to ask is how AI can be used in healthcare. I'm going to click submit. And now I can see it's processing the request. If you see the backend, you can see those files are getting loaded, then downloaded, then those PDFs are converted to text, then divided to chunks, then saved in embeddings format. Finally, we'll get an answer. Now I got the answer here. Based on the provided context, AI can be used in healthcare in several ways. Personalized treatment recommendations, deployment of simple assistive tools, improving public health, economic opportunities, solving health-related issues, and much more. I am really excited about this. Now you can run and search for research-related articles and use a large language model to question those articles completely locally on your computer using Ollama. I'm going to create more videos similar to this, so stay tuned. I hope you like this video. Do like, share and subscribe, and thanks for watching.